Good morning. Today we are going to discuss the BSc second semester topic Coligative properties of dilute solutions. In this we are going to discuss elevation of the boiling point. So topics to be discussed in this lecture. What are coligative properties? Types of coligative properties. Elevation of boiling point. Relation between lowering of vapor pressure and elevation of boiling point. Determination of molecular weight from elevation of boiling point. Experimental determination of elevation of boiling point by Cottrell's method. Some problems. So first we'll see what are colligative properties. Colligative properties depends only on the number of dissolved particles in solution and not on their identity. These colligative properties are mainly four types. The first one is lowering of the vapor pressure. Second is osmotic pressure. Third is elevation of the boiling point. Fourth is depression of the freezing point. So we already discussed lowering of the vapor pressure, and we also discussed osmotic pressure. So today we are going to learn about the elevation of the boiling point. So elevation of the boiling point, delta TB is equal to, that is the temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure is called boiling point. The vapor pressure of a solution is always lower than pure solvent, and hence it must be heated at higher temperature to make its vapor pressure equal to atmospheric pressure. Thus, the solution boils at a higher temperature than the pure solvent. This indicates boiling point of the solution must higher than that of pure solvent. So, boiling point elevation. The difference between the boiling point of a solution T and boiling point of a pure solvent T naught. So, the delta TB is equal to T minus T naught, where delta TB is elevation of boiling point, T is the boiling point of the solution, T naught is the boiling point of the solvent. Relation between lowering of vapor pressure delta P and elevation of boiling point, that is delta TB. The elevation in boiling point of a solvent is due to dissolving of non-volatile solute, and it is determined by the vapor pressure curve. So here the graph is taken between the vapor pressures and temperatures. So different vapor pressures of the solvent, dilute solution and concentrate solution at their boiling points T0, T1, T2 are taken. So in case of dilute solutions, the curves are parallel to each other. Hence the triangle delta ABD and the delta ACE are similar triangles. So then AD by AE is equal to AB by AC. So AD by AE is equal to AB by AC. So P0 minus P1 divided by P0 minus P2 is equal to T1 minus T0 divided by T2 minus T0. Then these two differences we can write as delta P1 by delta P2 is equal to delta T1 by delta T2. So delta P directly proportional to delta TB. From this we say that elevation of boiling point directly proportional to lowering of vapor pressure. Determination of molecular weight from elevation of boiling point. According to the Rolle's law, P0 minus P by P0 is equal to XB. That is a mole fraction of solute. So P0 minus P by P0 is equal to weight of the solute by molecular weight of the solute into molecular weight of the solvent by weight of the solvent. So P0 minus P is equal to, take out this P0 to this side. So WB by MB into P0 MA by WA. At constant T, P0 MA is constant. So delta P directly proportional to WB by MB into 1 by WA. From equation 1 and 2, delta TB directly proportional to WB by MB into 1 by WA. So delta TB is equal to, take out this proportionality, KB into WB by MB into 1 by WA. If weight of the solvent is in grams, the above equation becomes where delta TB is equal to KB into WB by MB into 1000 by WA. KB is equal to boiling point constant or molar elevation constant or ebullioscopic constant. If WB by MB is equal to 1 and WA is equal to 1 kg, then delta TB is equal to Kb. Thus, molar elevation constant may be defined as the boiling point elevation produced when 1 mole of solute is dissolved in 1 kg of solvent. Value of Kb. The constant Kb, which is characteristic of a particular solvent, is used, can also be calculated from thermodynamically derived relationship. Kb is equal to RT naught square by 1000 LV, where T naught boiling point of solvent, R gas constant, LV molar latent heat of vaporization. Next, we can also determine the elevation of boiling point by the experiment, that is by Cottrell's method. So these are the apparatures used in this method. So condenser, Bachmann thermometer, boiling tube, inverted funnel, and solution taken here. So it consists of boiling tube containing solvent. This is the solvent or solution, and inverted funnel with narrow steam. The solvent is placed in the boiling tube. It is heated very slowly. The temperature soon becomes constant, indicating the boiling point of the solvent. A known weight of the solute is then added to the solvent. The boiling point of the solution determined. So the boiling points of this it can be determined, that is by using this thermometer we can note down the temperatures. So the difference between the boiling point of the solution and solvent gives the elevation in boiling point. So that is delta TB is equal to T minus T naught. Next we'll do some problems. So the first one is latent heat of vaporization of benzene is 94.3 calories per grams. Boiling point of benzene is 80 degrees centigrade. Calculate the molar elevation constant of benzene. So this is the latent heat, 94.3 kilocalories per gram. R is constant, 2 calories degrees per mole, and T naught boiling point of the benzene 80 plus 273, that is converted into kelvins, so it is 353 kelvins, and Kb is molar elevation constant of benzene that we have to calculate. So here Kb is equal to RT naught square by 1000 LV. So R is 2 temperature, that is 353 Kelvin, that is 353 into 353, so T square, so 2 times divided by 1000 LV, that is given latent heat is 94.3. So after doing the calculations, we will get the value 2.64 degrees centigrade. So this is the molar elevation constant of benzene. Next problem is a solution of 0.450 grams of urea, molecular weight 60 in 22.5 grams of water showed 0.170 degrees centigrade of elevation in boiling point. Calculate the molar elevation constant of water. So WB, so this is the weight of the solute, that is 0.45 grams given in the problem, and weight of the solvent, here the 35.4 grams of acetone is given. So MB is molecular weight of the solute, that is given here 152. Next T naught, so that is 56.3 degrees centigrade. Boiling point of acetone, that is, so Kb per 100 grams of acetone is equal to 17.2 degrees centigrade. Then T is equal to, that is, calculate the boiling point of the solution. So delta TB is equal to Kb into Wb by Mb into 1000 by Wa. So T minus T naught is equal to Kb into Wb by Mb into 100 by Wa. So T minus T naught is given here, 56.3 is equal to, that is Kb here 17.2. So this 17.2 into this weight of the solute 0.45 divided by 152 into 100 by 35.4, that is weight of a solvent is given here. This is, so substitute all these values, then after doing the calculation of this side, we will get T minus 56.3 is equal to 0.146. T is equal to 56.3 plus 0.146. So T is equal to 56.446 degrees centigrade. Next problem is 0.15 grams of a substance dissolved in 15 grams of solvent boiled at a temperature higher by 0.216 degrees centigrade than that of the pure solvent. Calculate the molecular weight of the substance. Molar elevation constant for the solvent is 2.16 degrees centigrade. So, weight of the solute is 0.15 grams. Weight of the solvent is 15 grams. Next, that is elevation in boiling point is 0.216 degrees centigrade. Next, molar elevation constant is 2.16 degrees centigrade given in the sum. Next, we have to calculate the molecular weight of the substance. So, delta TB is equal to KB into WB by MB into 1000 by WA. So, MB is equal to KB into, take out this MB this side. So, KB into WB into 1000 by delta TB into WA. So, MB is equal to, substitute the values, KB here 2.16, this is 2.16 into WB 0.15, this is 0.15 into 1000 divided by delta TB, this is 0.216 degrees centigrade. So this is the 0.216 into WA, where this WA is 15. So this is 15. Substituting all these values and doing the calculations, we will get, that is the molecular weight of the substance is 100. Next sum is 10 grams of a non-volatile solute is dissolved in 100 grams of water. This solution boils at 100.78 degrees centigrade. If the molar elevation constant for water is 0.52, calculate the molecular weight of the solute. So, weight of the solute is equal to 10 grams given here. Weight of the solvent is 100 grams. This is 100 grams of water. Next, temperature, that is boiling point of the solution is given, that is 100.78 degrees centigrade, and the KB is a molar elevation constant of the water also given in the problem, that is 0.52. So T0 is a boiling point of the solvent, that of water we know that is 100 degrees centigrade. So MB is the weight of the solute that we have to calculate. So delta TB is equal to KB into WB by MB into 1000 by WA. So MB is equal to KB into WB into 1000 by delta TB into WA. So we have to calculate the molecular weight. So we have taken this molecular weight this side. Then substitute the values of these ones. So KB is here 0.52. So this is 0.52. Next, WB 10 gram. Next, 1000 as it is. Next, T minus T0 into 100, that is WA is 100. Next, So 0.52 into 10 into 1000 by this T is 100.78 degrees centigrade. T naught is, that is 100. So into 100. So 0.52 into 10 into 1000 by 0.78 into 100. That after doing the calculations, we will get 66.6 as the molecular weight of the solute. Next problem. When non-volatile solute is dissolved in benzene, it boils 0.126 degrees centigrade higher than pure benzene. How many moles of solute present in 100 grams of benzene? Kb of the benzene 2.52 degrees centigrade. So weight of the solute is 100 grams. N is the number of moles that we have to calculate. Delta TB is the elevation in boiling point that is given in the problem. So this is the given in the problem 0.126 degrees centigrade. Kb molar elevation constant that is also given here. So that is 2.52 degrees centigrade. So the formula is delta TB is equal to Kb into WB by MB into 1000 by WA. So delta TB is equal to Kb into N. N means weight of the solute by molecular weight of the molecular weight of the solute, that is equal to this equal to N into 1000 by WA. So N is equal to, then take out this N this side. So delta TB will be this side. So delta TB into WA divided by KB into 1000. That is equal to 0.126 into 100 divided by 2.52 into 1000. Substituting all these values, then 12.6 into 100 divided by 252 into 1000. So here the taking out the decimals. Next, 126 into 100 divided by 252 into 1000 into 10. So 126 divided by 252 into 100. So what happened? Cancelling of the zeros. So finally we will get 0.005 moles. This is the number of moles of the solutes. Next problem is, what is the boiling point of the solution containing 9 grams of the glucose in 1000 grams of water? That is, Kb of the water is 0.52 degrees centigrade. So weight of the solute is 9 grams. Weight of the solvent is 1000 grams. These are given in the problem. T is equal to that we have to calculate the boiling point of the solution. So T naught is, that is Boiling point of the solvent water is 100 degrees centigrade. Kb is the molar elevation constant given in the problem, that is 0.52. Next, Mb is equal to, that is molecular weight of the solute glucose is 180. The formula is this: T minus T naught is equal to Kb into Wb by Mb into 1000 by Wa. So T minus 100, that is T naught is 100. So T minus 100 is equal to Kb is 0.52. So substitute this 0.52 into Wb. Wb is 9 and divided by Mb. Mb is 180. So thus into 1000 by Wa. Wa is 1000 grams this. So T minus 100 is equal to, after doing this all calculations, 0.026. T is equal to 100 plus 0.026. T is equal to 100.026 degrees centigrade. So this is the boiling point of the solution. Next topics are covered in this lecture is: what are coligative properties, types of coligative properties, elevation of boiling points, relation between lowering of vapor pressure and elevation of boiling point, determination of molecular weight from elevation of boiling point, experimental determination of elevation of boiling point by Potraw's method. So we did some problems. Thank you.